In this video, we will learn about InputStream class and OutputStream class. These are the base classes for byte streams. There are various classes that are inheriting from InputStream and OutputStream classes. So these are base class. If you want to understand all other classes, the first thing is you should understand InputStream and OutputStream thoroughly. So this video is for InputStream and OutputStream. So if you understand this, rest of the classes, you don't have to study them much, that are very easy to use them. So here I have InputStream class. I have written all the methods, right? There are only few methods. And the interesting thing is, if you understand these methods, these applies for all the subclasses. And you have to learn very little about the rest of the classes. So let us study this one. See, for explaining these methods, I have taken an example here. See, this is a resource. Data is present here. As I told you in the previous video, data may be coming from various resources. So this is a resource. Okay. I have mentioned data here. Data is present here. So what is the data? Alphabets are there. A, B, C, D, E. Alphabets I have taken. Now this is a program. And program is connected to this resource and it is taking the data as input using input stream. So it is getting the data from here, from the resource to the program. So for this we require input stream. So suppose it's an object of input stream that is connected to the resource and the program. Now how I can use this input stream class for fetching the data from there, getting the data. So for that these various methods are there. So what is the role of each method? Let us understand. So from this, the very first method, this is read, int read. This will read just one byte from this resource. So if you say read, this A will come into this program. If you say read, it will just read one byte. See, the return type is integer because byte is integral type. So that's why it is integer. It will be returning a byte, 1 byte data. So you'll get a byte. So 1 byte. Now one important thing. This whenever you use read method and once you read the data, it is not available in the stream. It is there in your program now. So remember this. So once you are reading, it means you are consuming. When you have consumed, it's not there in the resource now. So if you read, A will come here. Again, if you read, again B will come. So in this way, for reading all these alphabets, you have to go on reading it. So like total 8 alphabets were there. So you have to say read for 8 times. And what happens if you are still reading from it, once the letters are completed, then if it has reached the end of this data, then it will return -1. Means if there is nothing to read, then it will return -1. So this is about read. Reading just 1 byte. So I will write down that A back again here. Next, we have different versions of read. So once we have understood read, they are similar only. Now read in a byte array. So in our program, if you have already a byte array, 0, 1, 2, 3, 4. So total 5 size array. This is a byte array, suppose. Now we can ask read method to read the data from here into this byte array B. So the size of this array is 5. So it will read 5 letters from there. So it will read the number of bytes depending on the array size, byte array size. So instead of reading one byte at a time, I can read at once, I can read 5 characters or 5 bytes from here. So this will be filled with A, B, C, so on, right? C, D, E, and these are all gone from this data. Now F, G, H is remaining. So if you want to read just 1 byte, this one. If you want to read collection of bytes, this one. And this depends on the array size. Then there is one more read. This is also similar to this one, second one. But the only thing is inside this array, from where you want to read the data. So you can mention the offset. You can mention here, I want to fill the data from here onwards. You can mention offset in this array. You don't want to start from the beginning. From other position, you can mention the position. And also you can mention how many letters you want to read. So that's all about, this is about reading. I will write down those alphabets back again. Now, this we have finished. Reading 1 byte or array of bytes and so on. The next thing, available. This method will tell you how many bytes of data is available. Right now there are total 8 bytes. This method returns the number of bytes available in the resource. So before reading, you can find out how many bytes are available and you can read those many bytes. So before calling this read or this read, you can find out how many bytes are available and you can use this one. The next is skip. Suppose in this, you want to skip some alphabets. Let us say you have taken first byte and the second byte and you don't want to read 3 bytes, you can skip and jump here. So this will not be taken in the program, just they will be skipped and they are no more in the stream. They are no more in the resource. They are removed. It is just like you have discarded them, so you don't want to read. So you can skip how many bytes you want to skip. You can mention here. The next, these three are related. These three are related. I will show you this one. First one is mark. Mark. Suppose you are right now you're on this position, on this alphabet. As I said that once you say read, you have consumed a byte. That byte will come inside. And it is not there in this stream. That is not there in this resource. This is gone. It is there inside the program. But now these three methods, they are related. So first let us look at mark. Before looking at mark, just let me remind you, I said that if you read a byte, that byte will come inside the program. It is no more available in the stream or in this resource. This is here. You have consumed it. It is not there. But no, I want it to remain there only. Okay, put it back. Then what I should do? Use mark. Put a mark. So this is marked. Then after marking, read next byte, then next byte, then next byte. Now I want to go back to that mark, say reset. So again you are back on A. Then again you can start reading A. So if you don't want them to be removed after you have consumed them, you can put a mark and it remains inside the stream. Then you can continue reading. At one stage you can say reset, so that again it come back to that same mark. So you can once again read those bytes. So mark and reset, they work hand in hand. With a mark, you can put a mark and you can continue reading, and then you can say reset and it will come back. Now one more thing in this one. If you have put a mark, then how long you want that mark to be active? Suppose you are going on reading and reading. Suppose you reach till here. Do you want, still you want that mark? Are you interested in going back again to that mark? So how long this should be valid? You can mention here, mark, that is limit. Up to how many bytes that mark should be valid. So up to that byte it will be valid. If you go beyond that, that mark is removed. So if you reset, you can come back. If you don't reset and you cross the limit, then it will be void, means it will be removed. The next is mark supported. Now for this, I will say that every input stream doesn't support mark, cannot support mark, because the basic mechanism of stream is if you are consuming a byte, it is not there in the stream, it has removed, you have removed it if you consume. No, I want it to stay there only by putting a mark. So it's not possible. It is possible only if a stream is buffered stream, if it is having buffer. Already I told you that buffer is a memory area, right? So it acts as an extra memory for holding the data in the stream. So that's it. If it is buffered, then only this mark is supported. So that's why before putting a mark, we can inquire whether a stream supports a mark or not. So mark supported or not, it will return true. If it is true, then you can use the mark. So before using mark, make sure that is it supported or not. Then the last thing is close. So after using a resource or a stream, you should close the stream. So stream is like a resource. It is used for accessing resource. So you should close that resource. So close is the important method. So after you have finished, you should close it. So let us look at them once again. There are three methods for reading. One important method for checking how many bytes are available, and you can skip the bytes. Then you can mark and reset if it is supported. That's all. You can remember this. This is very simple. Mainly read available. Mark and reset is rarely used. It's not common. Skipping is also not common. Available is useful, right? So you should know how many bytes are available. Close. So important methods are read, available and close. Rest of them are rarely used. So that's all about input stream. So we have studied about all the input streams because all of them are inheriting directly or indirectly from input stream. So we know about all of them. Next I will show you output stream. So let us look at output stream class. Already I have written the methods, but before that let us understand the diagram. See, here is a resource, external resource, and the program is having the data and program is going to write on this resource. Resource can be anything, like it's a monitor or a file or a network, so it's going to send out the data. So for sending out the data from the program to a resource, we need output stream. So we don't have to read now, we have to write in this one so that it is sent onto the resource. So methods are there for writing. Just like read methods are there, similarly we have write methods. There are three versions. Write B, 1 byte. It will write just 1 byte. So you can write A. Let us say I have an array here, array of data. So from here I can send A. So A is sent and it is received in the resource. So it will be written in the resource. Likewise, I can use write repeatedly in a loop and I can write on all the letters, all the bytes, whatever I have. So this write will write just 1 byte. If suppose this is a byte array and I want to write on all the bytes together, then I can use this method. The next is write method with a byte array, offset and the length. Means you don't want to write from the beginning, first letter onwards. You can start from third byte or fourth byte. So you can mention the offset and how many bytes you want to write down. So you don't want to write the entire thing from starting point to ending point. So you can mention the starting point and the number of letters or bytes from there. So these are three versions of write. Now the next is flush. Now this will not work on all output streams. This will work on buffered output stream. Suppose there is a buffer. Buffer is a temporary memory object, right? Suppose there is a buffer here and you are writing in the buffer. So this buffer may get filled, right? It may be having alphabet. Suppose if you are writing A, so A is here, then B is here, then C is here, then D. It's not yet sent out. So if you use a buffer, usually the data that is written is kept inside buffer. And if you want to push it on this resource, then you have to say flush. So flush means it will flush the data from buffer to the output stream. Means it will force the data to flow out from the buffer, reach this resource. So this is for forcing the data, flushing the data. It is useful if buffer is used in output stream. And the last thing is close. So once you have finished using output stream, you can close the output stream. So it's a good practice to close it. So that's all about input stream and output stream classes. Directly we may not be able to use them, but the subclasses of this one we can use them. So in the next videos we will be learning about their subclasses. So from there you can see the demonstration and the programs that are using streams, that is input stream and output stream classes. So that's all in this video.